Hello, my dear physics friends. Welcome back to the part B of Cambridge Igcse Physics, paper 63, October November 2023. Let us start with the third question. Question 3. A student determines the focal length of a converging lens. She uses the apparatus shown in figure 3.1. Part A. The student sets the distance u between the illuminated object and the lens to 20 cm. She moves the screen until a sharp image of the illuminated object is seen on the screen. She then measures and records in table 3.1 the distance v between the lens and the screen. Describe a technique to obtain an image on the screen that is as sharp as possible in this experiment. Include in your description where the screen should be placed initially, how an accurate position for the sharp image is obtained. So, in order to get the image, the screen should be in front of the lens, either towards or away from the lens. Then in order to get the sharp image, the main point we need to remember is we have to move the screen slowly towards the lens or away from the lens. The 2 points, two answers are slightly confusing. For first part, the screen should be in front of the lens in a horizontal table in the same plane. And second one is to get the sharp images, screen should be moved slowly. That is the main point. Then moving to the next part B. The student repeats the procedure for object distance u is equal to 30 centimeter, 40 centimeter, 50 centimeter and 60 centimeter. Her readings are shown in table 3.1. So clearly first column is object distance for 20, 30, 40, 50, 60. Second column is image distance 60, 27.3, 25.3, 21.4, 20.0. If you observe the values in this table, why they have written 20.0? We know that 20.0 value is 20. 60.0 is 60 only. But they made it three significant figure. So when you calculate u by v for the first object distance and image distance, we should remember that it should be three significant figure. If you see the third column also, u by v values all are three significant figure. The last one 3.00. So purposely they made it three significant figure. So we sometimes when we are calculating also should remember in our mind that it should be three significant figure. So let us see the question. For distance u is equal to 20 centimeter, calculate and record in table 3.1 the value of u by v. So as I told, when we are calculating u by v value for the first row, it should be three significant figure, and when we calculate it, it is 0. Part C. Plot a graph of u y-axis against u by v on x-axis. Start your graph at the origin. Draw the best fit line. So these graph questions are very easy questions. We can gain marks just by representing correct quantity with unit on y-axis, correct quantity on x-axis with unit. In this situation there is no unit because u by v don't have any units, and choosing the scale so that the graph sheet is maximum part of graph is utilized. So let us see the next question. When our graph is given, obviously there will be a question to find the gradient. To find the gradient y2 minus y1 by x2 minus x1. Let us see. Part D. Determine the value u naught of u when u by v is equal to 0. So when u by v is 0, the value of y-axis is not 0. In this situation, when u by v is equal to 0, there is one value on y-axis, that is by extrapolating the graph on y-axis, it cuts the y-axis at a particular number. So that is usually called y-intercept. So that y-intercept value we need to write here. But by drawing with thick pencil lines, thin pencil lines, or by slight variation of the scale, uh, different student will have different slight variations. So there will be a range. So if our answer is within the range, it is correct. Part 2, the gradient of the graph is numerically equal to the focal length f of the lens. Determine the value f for this experiment. Show clearly on the graph how you obtain the necessary information to determine the gradient. So uh, the information is clear. Focal length is equal to gradient. So we know what is the formula for gradient: y2 minus y1 upon x2 minus x1. Clearly, just substitute the highest value of y-axis 60 minus 20 and x2 minus x1 values also. If you substitute correctly, it is the focal length with the unit you have to write. Then part E, suggest one precaution that can be taken to ensure measurements are accurate in this experiment. So in order to get the accurate values of image distance or focal length, we need to clamp the roller on the bench where we are performing this experiment. And one simple precaution for the students is, during all light experiments, usually we need to perform the experiment in the dark room. So that is one precaution. So that is a simple one. With this, third question is completed. Let's move on to the next question. Question number 4. A student investigates the brightness of a lamp. Plan an experiment to investigate how the intensity, brightness of light produced by the lamp is affected by the current in the lamp. The apparatus available includes a lamp and power supply, a light meter which measures the intensity of light arriving at it, an ammeter, a variable resistor. In your plan, you should complete the circuit diagram in figure 4.1 to show the variable resistor connected to control the current in the lamp. In figure 4.1, there is an incomplete circuit. So we need the correct symbol of variable resistor, and that should be drawn in the series connection. So it is clearly shown with the red color. Just observe it. Question number 2. State the key variables to be kept constant. If you observe the question carefully, variables to be kept constant throughout the experiment, those variables are constant. So what we can change is amount of resistance. By changing the resistance, current can be changed, but what we cannot change is the type of lamp should be kept constant. And light meter, distance between light meter and the lamp also should be kept constant. So those two comes under the key variables. Third question, explain briefly how to do the experiment. This is procedure. So we can write the first point: set the variable resistor to a lower value and measure the amount of current in the ammeter and note down the value in the light meter. Repeat the experiment for different currents and note down the value of light meter and tabulate them. Next question. Draw a table with column headings to show how to display the readings. You are not required to enter any readings in the table. The values are very simple. The table columns are only two. First column is current with the unit amperes. Then second column is light meter with the units. Actually, it is intensity of light, the amount how bright it is. The units are candles. Only two columns. Current with the unit amperes, and second column is light meter with the unit candles. Explain how to use the readings to reach a conclusion. This conclusion part is very crucial. We need to write clearly. It is for 2 marks. First, we need to observe and compare the readings of light meter for the different values of current. And second part is, we need to plot a graph of the value of light meter for corresponding currents. When we plot, it is a straight line. This also should be mentioned, because when the current is increasing, brightness also increases and the value in the light meter increases. So it is directly proportional. Just Look at the answers how we have written for the discussed questions. All the relevant answers. Key variables are type of bulb or lamp used. Second one is distance from bulb and light meter. Procedure: complete the circuit connections with correct symbol of variable resistors. By varying the amount of current in the ammeter, check the light meter. Repeat the experiment with the other currents. Then table is current, its unit is ampere. Light meter, its unit is candles. Conclusion is compare the readings of light for different currents by varying the resistor. Plot a graph of light intensity against current. So with this, we have completed fourth question. Thank you so much for watching this video explanation. Soon we will meet with the explanation from 2024 papers.